Katie and Tyler work together to prepare a meal at a soup kitchen in 2 6/7 hours. Working alone, it would take Katie 6 hours more than it would Tyler. How long would it take each of them to complete the meal working alone? So using the work principle, we have the total time working together, 2 6/7 hours, 2 6/7, over the amount of time it would take Katie to work alone, K, plus total time working together again, which was 2 6/7 hours, over the amount of time it would take Tyler to do the job by himself, let's call that T, equals 1. Something else that we know about the problem, we're also told that it would take Katie 6 hours more than it would take Tyler. So K would equal T plus 6. So we're going to make that substitution also with our equation. We're going to let K equal T plus 6, and also at the same time we're going to change 2 6/7 into the improper fraction 20 over 7. So we would have 20 over 7 over K, which is now T plus 6, plus 20 over 7 over T equals 1. And we're going to go ahead and solve this equation for T. So to solve this equation for T, we're going to multiply both sides of the equation by T times T plus 6. Multiply both sides by T times T plus 6, and multiply the whole left side by T times T plus 6. So using the distributive property over on the left hand side, the quantity T plus 6 divide out, so we're left with 20 over 7 times T, which is 20 over 7T, plus when we multiply T times T plus 6 times the second term, the T's divide out, leaving us with 20 over 7 times the quantity T plus 6, and over on the right hand side, 1 times T plus 6 is just T times T plus 6. So we'll go ahead and use the distributive property twice. We have our first term, 20 over 7T, plus, now using distributive property, another 20 over 7T, plus 120 over 7 equals T squared plus 6T. So we see we're going to end up with a quadratic equation. I also notice that my T squared term is positive right where it's at, so let's get our 0 on the left side of the equation and move all of the other terms to the right side of the equation. So first off, we have this 20 over 7T plus 20 over 7T, and that would give us a total of 40 over 7T, but we're going to move that over to the right hand side of the equation. So we have a T squared, we have our existing positive 6T, and now that 40 over 7T becomes a negative 40 over 7T over on the right hand side. We have a positive 120 over 7, and over on the right hand side becomes a negative 120 over 7. So now we'll go ahead and combine like terms. We have our 0 equals T squared. We have a 6T minus 40 over 7T, and when we combine those like terms, we end up with a positive 2 over 7T, and we have the minus 120 over 7. Now we'll eliminate our fractions. We're going to multiply everything by 7, so multiplying both the left side and the right side of the equation by 7 gives us still 0 on the left, gives us a 7T squared plus 2T minus 120. And we'll go ahead and solve this quadratic by factoring. So we check the GCF, and we cannot factor anything out of all three terms on the right hand side. So we'll try to factor this trinomial as the product of two binomials. There's only one way to get a 7T squared, and that's 7T times T. And the other values that we need would be a positive 30 and a -4. And as you can see, if we FOIL this back together again, if we multiply this back together again, we will get 7t squared plus 2t minus 120. So now we set each factor equal to 0. So we have 7t plus 30 must either equal 0 or t minus 4 equals 0. And on the left-hand side, solving for t, we would get t is equal to negative 30 over 7, or t is equal to positive 4. And recall that t was the number of hours that Tyler would need working alone. So time cannot be a negative value, so we throw out the negative 30 over 7. So we get our first solution of t is equal to 4. So it would take Tyler 4 hours to perform this job all by himself. We'll grab that t equals 4 and we'll run up to the top where we know where the number of hours Katie would need working alone would be t plus 6. So that would imply then 4 plus 6, t was equal to 4, is equal to 10. So Tyler would need 4 hours to complete the meal working alone, and Katie would need 10 hours.